Look, we really we were proud of a lot of the work we did with the JavaScript code base, but also we were really hitting diminishing returns on the sorts of optimizations. So I guess in retrospect, like maybe 2x could have been worth it, but I think it was nice that even single threaded, we were seeing already like 3 to 4x in some cases, right? And then once we added like, okay, now actually do all the parsing and do it all in parallel. Okay, it's at least 8x, if not 10. And actually, it was not until we started like doing parallel checking that it was like truly 10x. And that, so I think like that being able to say that number was what was driving us. Like, no, how much farther can you get there? And then it was like, okay, you really can't ignore that.
Welcome to TypeScript FM, the friendly podcast for TypeScript developers where we bring you news, updates, and interviews from the community with plenty of tomfoolery sprinkled in. I'm your host, Kamran Ayub, and I'm joined by my co-host and best bud, Eric Onerheim. Together, we're the two TypeScript fools. Welcome to the show. Hey everybody, welcome to the show. Today, we are going to be talking about TypeScript 6.7 with the TypeScript team members, Daniel and Jake, who I'm sure you know very well, but we're still going to introduce them and have them introduce themselves. Jake, Daniel, welcome to the show.
Hello.
Thanks for having
Daniel, do you want to introduce yourself first?
Sure. Hi there. My name is Daniel Rosenwasser. I'm the product manager on the TypeScript team. And I started off years ago as an engineer, switching to PM. And then we have...
Jake. I've been working on TypeScript for, I don't know, a few years now. I can't remember. I don't remember how old I am. But I'm a software engineer. I've been working on the team for a bit. I just do lots of big migrations, apparently.
In my mind, Jake, you're sort of like the face of the Go port. And I mean, we both actually watched your GopherCon presentation. It was fantastic.
It was.
Yep. But I mean, the whole team has done such a great job with this new stuff. But one thing that we were thinking about is like what we want to talk about on this episode is not just about the Go port, but we also just want to talk in general about what's coming up for TypeScript 6, which is the next version of the current sort of release branch of TypeScript. And then after that, what's coming in TypeScript 7, which is the Go port, and to help people try to navigate what's going to be coming up.
Yeah, we know that, like, you know, everyone's talking about the Go stuff, but like, I feel like 6 is not getting a lot of love.
Yeah, do we just want to start with like what's coming in 6.0?
Yeah,
Sure.
I pulled up the list.
Yeah, me too, actually.
Nice.
It's a lot of stuff that isn't merged that's supposed to come in, but you know.
Yeah. I guess, you know, like you mentioned, right? There's so much focus on 7.0. And funny enough, right? What 6 is all about is 7.0 still. Because fundamentally what we're doing with 7.0 is we're porting the compiler, we are porting the tool set, but we are trying to make sure that we're thinking about all of the sorts of gotchas of both our old architecture and what it is to like develop a TypeScript project today, right? So, for example, things like the feedback that we've gotten from people is, why do I have to set so many specific things in a TS config to get so-and-so going, right? In a modern project, don't I always want strict on? Don't I always want these specific things? You can't see it necessarily, but Jake is wearing a strict true t-shirt. Eric is wearing the types, the Doom types t-shirt.
Love it.
Okay, yeah, amazing. So there's a lot of best practices that we kind of saw as an opportunity to say, well, with 7.0, we don't just want this thing to be amazingly fast. We also want it to sort of demarcate where we're going with TypeScript in general, right? Like this is where the ecosystem should go. And so the vision for 6.0 is that it's really a stepping stone to get to 7.0. 6.0 is the same code base that we've been working off of for the last 10 years plus, right? It's still the JavaScript-based or TypeScript-based code base that I guess compiles to JavaScript and runs on Node.js. But the big thing there is that it it is supposed to be configuration compatible, and as much as we can, checker compatible as well with 7.0 to get you in a good state. Meaning that if you take a TypeScript project that compiles in 6.0, it should compile in 7.0 with no adjustments, with some knowledge that there are some deprecations coming and things like that to ready you for 7.0 too.
Yeah. Should we talk about some of those?
Yes. Let's talk about the code we've deleted. Amazing.
It's the most platonic ideal is deleting code. Less code runs really fast.
So one of the things that we mentioned was the vision of, and we get to strict true by default, right? So that is a big one that I think a lot of people are really excited for. Even though, most people are just setting strict true and running with that, or I should say most people writing a new project, right, are doing that. But we also have a couple other things like the target, right? So for example, we've defaulted to going as far back as TypeScript supports for a couple of years now when it comes to compiling code. So if you take some code that has, an optional like every new ECMAScript feature or every new JavaScript feature that's come out in the last 10 years, if you don't say otherwise, we're going to just take all of that and compile it down to, until a couple of years ago, it was like ECMAScript 3.
Yeah. Wow. We're so new now at ES5,
Yeah, right. And now we compile down to ECMAScript 5, right? So like the big difference there was we stopped rewriting keywords like default in properties with like quotation marks and things like that, right? So with ECMAScript 5, right? Like if you think about what that is, that's actually compiling all the way back down to something that works in not even Internet Explorer 11, because that kind of had some support for, I think, ES6 or ES 2050. So we were thinking, this is fundamentally not how the world is anymore, right? Like back then, it made sense. You were running on a handful of runtimes. They were not evergreen runtimes, right? JavaScript runtimes, that is. And nowadays, most people are running in a browser that's like within 2 years old, right? Probably newer, but still, there is always the whole like, I have an Android phone from like 5 years ago, and that runs like an old version of like an embedded Chromium or something like that. But that's not how most people are running. So we wanted to encourage people to use a newer target, right? So another example of this is that our target is no longer like defaulting to the oldest possible version. It's defaulting to the most stable ECMAScript version, right? So ECMAScript 2024, right? Basically, if you have a new feature that lands in JavaScript, we're not going to rewrite it for you by default, because chances are if it's already in the standard, you can run that in your browser today. So why are we going to rewrite that? It's going to be easier for you to debug it. It's going to be like cleaner in the output. So things like that. And Jake's been doing some of the work on that more recently, right? Like you can talk about like lines of code removed and things that. Yeah.
Yeah, the worst part is just our test suite. The default is obviously like ES5. And so if you want to change the default from ES5 to ES 2024, every single test, which never said what target it wanted, needs to change. And you get to like, I'm currently working on one flag that is affected by this, and it changes 2,000 test files. And I'm just like, okay, how does this, is this okay? Is this correct? I don't know. I'm probably going to give up and just mark them all as like, yeah, okay, this needs to be the old way. It's because our old default used to be, if your target was ES5, then we would automatically emit CommonJS, which is like, for back compat reasons, that's not unreasonable. But at the same time, it's like, we have, how many tests do we have that wrote export, but it wasn't important to the test? Like a lot of those. That's my side thing as I'm trying to like rip out ES5 and okay. To be clear, I'm not ripping out ES5. ES5 is being deprecated in 6.0, right? But then in 7.0, we haven't ported the code. And so rather than us like porting the entire code base and then deleting the part of the stuff we just ported, we're just not porting ES5, right? And in terms of like the annoyance of porting code, the further you go back, the more annoying the feature is to deal with. Like, okay, now I have let const, I got to turn into var. Like, okay, well, what the heck is the scoping rules on that one? Like, avoid that. Like getting rid of classes and turning them into functions again. It's like, what year is it? Like,
are you like just in the spec? Do you have like a printed copy of the ECMAScript spec on your desk?
If I load the spec, it crashes my browser. I don't know.
There's a multi-page spec, by the way, just so you know. Yeah.
I don't know. I've spent enough of time in the spec trying to port numbers, stringification, and number parsing to be unhappy. So
Yeah. I mean, I don't know. I don't know if we want to go too off tangent here, or off topic here, but too off tangent. I think
tangent.
Yeah.
Wait, tangent of a tangent. That's just parallel. What do you mean?
It's the second derivative
Secant.
of anywho. The point is, I mean, thankfully we sometimes get knee deep in the ECMAScript spec, and it used to be a nightmare, and there's been so many authoring changes to make it like easier to explore that, and so I don't know. I guess call out to all the people who've worked on the tooling for the spec as well. But we do have to like look into stuff like that. I mean, for example, in the 7.0 port, right? Like Jake had to do a whole bunch of stuff to emulate the numeric computations within JavaScript so that like our enums would behave the same again, right? Like we do some.
Well, because like here's the problem. You literally, I mean, here's an example. You write a goofy number in JavaScript, and then you put that in a TypeScript template type. That's supposed to stringify it. Okay, well, there's nothing stopping you from writing 1000000.0000001, and then like you better round trip that the exact way that JavaScript does, right? Because we benefited greatly from being in JavaScript before, because you just will say parse number and you move on.
Right.
Okay.
You have the interpreter with
you for
you.
the stringification. But now we're in Go, so it's like, well, can't really do that. Thankfully, most of the heavy lifting is done by Go's JSON package, because the JS in JSON is just JS, so that's great. And then every language, they all have decided correctly that the way to represent floating point numbers is with the absolute shortest possible representation, so they don't deviate from each other, except for weird edge cases in QuickJS that I discovered. But so they'll use the same algorithms like Ryu and Dragonbox and whatever else is going on over there. And
I do have a question about the target deprecation for developers who are used to using TSC directly to do their compilation. They would want to update their target, or by default, if they do a TSC init, it's going to be ES 2024, right?
Already today, if you are in 5.9 and you do TSC init, we will put the target higher.
Okay.
This is mainly if I just make a TS config and I put nothing in that config box, like what happens? And that's what we mean by the defaults. And like there's a world in which like you could say maybe that means that the TSC -- init can contain less stuff because we're going to maintain that, in the future. That's a good thing. People don't, we saw when in 5.9 we introduced, was it 5.9 or 5.8? I can't remember. We had the giant thing with all the different options. Then we compressed it down. It's like, how far could we possibly compress the thing is one direction that we could go there. But it's also just like signaling that we're trying to be, modern with this, right? That like, please people, like think a little harder about your target. Anyone else, I think it's probably the case that most people are setting their target explicitly and they don't need to think about it, right? And so they set it, but maybe this is a PSA of like, you haven't looked at your TS config in a while, you should reconsider whether or not the target you set in there is fine. And if you've set ES5 or ES6 and something ES 2015 or something, maybe consider going a little higher if your version of Node you're using is high enough. And if you're doing a browser, you could go ES 2024 and probably be fine, or you don't, or it doesn't matter because you're using some bundle that does something else anyway. But
that was actually my next question, which is if you are using like a bundler, let's say Vite, and I'm using a TS config, does it matter what target I put in there? Should I always do ES next? Is that kind of the recommendation, or how should I be thinking about that?
I think so, but also if you're using a bundler like Vite, they're going to be doing the rewriting for you typically, right? So this is always a subtle point. If you're using some other build tool, whether it be Vite, ES build or SWC, Oxy, like any compiler, if it's happening out of band, and if TypeScript's API isn't being used for doing the transformation, you actually want to set no emit, right? Because something else is going to be doing that. It's concerned with like the output directory, things like that. And so we would typically say, no, you actually just want to target ES next, because we don't want to give you any errors saying like, oh, well, this construct isn't supported in this so-and-so way, or like, this is not going to work at runtime, because actually your other build tool knows better about that, right? And maybe they'll do something different. Maybe they'll provide a polyfill, something along those lines. So, for some users, this actually doesn't affect you at all because you're going to be using something like, if you're using the built-in JavaScript or TypeScript support in Node.js, right? Like they're going to be doing that the type stripping, right? So it really comes down to whatever target you're going to be, like whatever runtime you're trying to target, right? And then whatever build tool you're going to be using. You also brought up another good point, which is like I said that we were changing the default of like our output, but I didn't actually mention the deprecation. You all kind of mentioned that there is some like the deprecation, which is we're not supporting ECMAScript 5 as an output target in 7.0, and so we're deprecating it in 6.0, right? So that's kind of the path that we're taking is like if something is not going to be in 7.0, it's going to be deprecated in 6.0. So you have a more gradual path. You can use the ignore deprecations flag in 6.0 to kind of like silence it temporarily.
You have time to get right with God.
I mean, there's a big laundry list of deprecations, and they're not even all merged.
Yeah,
or even PR'd.
But a lot of the time, it kind of signals. To go back to your metaphor, it kind of like makes you reckon with your choices, right? It makes you actually ask, do I need to be targeting ES5? Do I need to be using this module resolution mode or this specific target or whatever, right? Like another one of these is that if you start a TypeScript project today, you'd have to set a specific module and you'd have to often specify a specific module resolution as well, depending on what you're trying to do. And we had this mode called like module resolution classic, I think. And it was just like, it comes from a time when nobody knew what modules were going to do and how they looked and all this other stuff. So it was this sort of heuristic of like, I'm just going to, like, what TypeScript would literally do under this mode is it would just say, you're looking for some path called blah. I'm just going to keep walking up over and over and over again in the parent directories looking for like blah.ts over and over again. And that kind of works for some stuff. It didn't work for like anything in NPM at all, like anything in your node modules. But, it was from over 10 years ago. And like that stuff was not really established at the time.
And that's like all the same sort of thinking as like why was the module default like common JS? It's like, well, ESM didn't exist as a runnable thing. Like if you wrote ESM syntax in TypeScript back in the day, what you actually meant was please turn this into common JS or I guess system or AMD or UMD or these other things that are being deprecated, right?
Yeah.
Good times.
Yeah. And common was kind of like the best we had at the time. And, we've talked about this before, but ESM had like a couple of, I don't know, strategic challenges to adoption that has taken 10 years, like to fully shake out, because at some point you need to have this non-virality in order for people to adopt it. And only very recently have we had like compatibility shims that are high fidelity enough for you to do that in like Node and other runtimes.
Yeah.
It's also just funny. It's just like require ESM, I think, is like the big one that's like, yep, okay, now we're all fine on ESM now. And it's just like, watching Joey do that. And I'm just like, their explanation of like, oh yeah, this has actually been possible for a while now. And no one bothered to look like what we could have had. Oh, well, we have it now and everything supports it now. But
it's definitely frustrating. And at the same time, there was a lot of background stuff to make it kind of possible and like somewhat spec compliant to do these things as well, or basically like deliberate whether or not it was. It feels bad to say this, but the whole the ability to require an ECMAScript module, not having that is basically our version of like Python 2 to 3, more or less, right? Like in the Node.js ecosystem, right? We have this sort of lost generation of like, it's the same pattern, right? Like 10 years of people saying like, oh, we're gonna not be able to do this thing, right? And it took 10 years before it became feasible to write packages. But it's not like we just moved on and started writing ECMAScript modules only. Like we actually added the compatibility, and that's actually what unblocked us. So it could have been longer, right? It could have been worse. So I think it's an unfortunate pattern. It happens a lot in software. It's not the only example, but like that's probably the one that resonates or is known for most people. And it feels like really relevant in this case, right? I'm so glad we're there.
Mm-hmm.
I'm a little bit disappointed that we now have a Go-based code base. I'll also say that like 5 times fast. But we really can't, we don't get to take advantage of that, right? Like we basically can't say like we're moving to true ECMAScript modules and it just works with everybody, because now we're like, actually we just have a faster code base and it's all in native code.
I spent a year maintaining that PR on our code base and getting it working and getting Node to add an API to make it possible that other people also need, and going through like trying to see if the spec would change to allow like synchronous imports and so on. And then I just closed the PR like a few weeks ago or something. I'm like, yeah, well, it doesn't really make sense now because like it's all going to be different. And the new code base, like it's all like ESM anyway.
Yeah, it sucks when you have good ideas and then you have other good ideas that make them not use. I don't.
The arena of good ideas. Does the goodest win?
Yeah, the goodest.
Yeah. Well, there's a thing that I talk about a lot when we're doing like architecture design at my company is like there is no meritocracy. Sometimes the goodest idea doesn't win.
I like that.
Well, we've talked about targets. We've talked about module resolution. Are there any other big deprecations you think people should be aware of that are coming?
Well, I can list my favorite one. It's not a deprecation per se.
Love
It's
it.
my favorite because I did it and I pushed so hard to make it happen. Okay, did you know that there is dom.iterable and dom.async.iterable?
Yes.
Mm-hmm.
I'd be willing to bet that most people don't know that those exist. And in fact, dom.async.iterable is missing from our help message, which is very funny, or from our website, that is. Yeah, so like there's dom, which is kind of misnamed. It's like web types, right? And that's under at types web as well. But like we include it, but then it doesn't include a whole bunch of stuff because it requires symbol iterables, all the iterable interfaces, then all the async versions of those. And so if you want to get those in your code and like do like a for loop over an elements list or whatever you get back from like query selector or whatever that's going on there. I'm not a DOM expert. Then you would have to include these extra things, and it would be like, well, it's not working. And then we get people filing bugs that are like, where's this declaration? And we're like, well, you got to include this extra thing in your lib. And since we're dropping ES5 more or less, we're like, okay, well, so the bottom is ES6. So ES6 means you're going to get symbol and you're going to get iterable. So we were like, okay, can we auto include it if we detect that your lib is set to this? And eventually we just decided like, no, actually, whether we're done with this, let's just make DOM evergreen, which it kind of is. Like it contains breaking changes release to release, and new stuff appears and disappears even as the specs move along. And so now in TS6, and this is unconditional. If you say DOM, you're going to get DOM plus the iterable types plus the async iterable types. And so you don't have to think about it, with the caveat that like you can't avoid loading the ES6 types and then also the ES 2018 async iterable types. So like if you're really relying on like, oh, I'd really like to target ES5, 1, who are you? 2, now it'll just appear for most people and they don't have to think about it anymore. And so now it's all one big DOM file. You load it all, you get it all. And that whole thing is just gone. We don't have to think about it. And I'm very excited for that, just because it's like, I know that I joined the team and I discovered this file. I'm like, what the heck is this thing? And why is no one including it in their types?
This is going to be great for us because we have a coroutine implementation that relies on those things. So when people are using coroutines, because I solve all my problems with coroutines lately, that affects them,
Yeah, and I've been burned by this too, with like adopting, I don't know, I guess I can't name any names, third-party libraries that want to use those type of features. They always have a step in their like TypeScript configuration, like you have to add these types to your lib. And so on behalf of those libraries, thank you for doing this.
Yeah,
it's just kind of frustrating because, like, I mean, if you look at it, like who's not enabling ES 2018 at least, like in their configuration, like it's everyone, and yet these DOM types don't appear because they're technically in a separate file. Like it's kind of annoying. So
yeah. The tip, like the only, I mean, you can imagine the scenarios, right, where this could go wrong, right? You can imagine people saying, well, we have a very locked down, version of this browser that we target only in our corporate environment, and we'd want people to not accidentally try iterating over this collection which was not yet iterable or something like that, right? Something where basically for of is not really supported in so and so ways. And So while that's possible, most of those things, I mean, you are really going far back now at the point where like these things are not supported is the thing. So it's not like we don't get it, but also those sorts of major divergences, right? I think like people really understand that ECMAScript 2015 and then for a couple of years afterwards were these big steps of filling in gaps that people were like, oh, it is so painful to get these things done, and we need these features, and it really, really makes it like a world of difference. It's not like differences, new things are not coming in JavaScript, but the major changes are not, it's not like this thing where, oh my gosh, I have a completely different runtime now, and so I think you are better off just having like a simplified experience there. And then, maybe there are certain tools that can help flag, like, don't do this construct. Like, you can put that in your linter or whatever. But the browser environments are largely evergreen, right? So that should, if you include the DOM types, just make it easy for most people, right? So I think, yes, it's a nice simplification. It's a nice win, right? And happy we got that in there too.
So I had a question in TypeScript 6 around breaking changes. There's a lot of ill-advised tool use of like internals of the TypeScript compiler, like just directly referencing JavaScript files that are inside the npm package. And this feels like a good spot in TS6 to be like, okay, guys, don't do that. You should use this other thing.
I don't think the goal of 6.0 is to break that particular element.
Well, not break it,
Yeah.
but like, like helpfully be like, I don't know if there's a way to do it in a way that doesn't hurt.
I guess the big thing, it's not like we were upset that people were using any of the files or like APIs that were specifically in TypeScript, right? Like, there's definitely, so it's JavaScript, right? So you often could still get at the internals, even if they're not documented, right? Like as long as it's on an object and you can reach it, and it's like, people would use, I guess, what you'd call private APIs, right? Undocumented, hidden from the outside. We would specifically mark these as internal, and then they become part of your API anyway because like some major tool uses it. I think one of the best parts of like how we design TypeScript is also like a little bit of the curse, which is, we had a lot of these APIs. We wanted them to be reachable in some capacity, but also like, were they the best API design? Did they allow us to sort of move over time and have something that was like, abstract enough that you could still do something with it, but, whatever, or was it even easy to use? And arguably, like everyone who used our API was always a little bit upset. They were like, I mean, they were happy that they were, oh, it's really cool. This is possible. And then when they would say that to us, I'd end up saying like, I'm sorry, because I know also what you're thinking was like, what a pain in the butt this was to actually do. So I think there's that. 6.0 isn't going to be changing API, any API reachability at all, right? It is more the case though that with 7.0, because we're in a different language with a different runtime, that there's absolutely no way that we're going to rebuild that API,
right,
or try to emulate it, comprehensively or anything like that. And so there are a couple of different directions we've explored with API, right? Like one of them, like Jake can enumerate all of them, but the one that we're sort of leaning towards is doing some sort of IPC. So the same way that like the language server protocol works, like the way that TypeScript talks to your editor and tells it like, oh, here's how to get a definition of something, here's how to like find all the references, or here's what the completion list is. That all just goes through like standard IO of another process, right? So something similar would happen here, where we would open up some sort of communication, and maybe we have some shims to make this easy to use in JavaScript in some way, but basically we are looking at what it would take to do that API. We don't think we'll have it in 7.0 off the bat, but we do think that we'll have it not too far afterwards, right? Because a big part of what we're thinking with 7.0 is like, you're still going to get a lot of good use out of a faster compiler and language service, right? So you don't want to stop people, like there's going to be a big part of the TypeScript user base that still benefits from that. We don't want to stop them from being able to get at this thing. In fact, I actually kind of want to like really briefly pause and just call out to everybody who's listening. We have previews of the compiler and language service that you can use today, and they're really solid these days too, and they have a way more of the features since we first announced them. right? So I'll say, like, if you're like, oh yeah, I heard that there's like a rewrite, actually go try the language service out right now. It's actually, if you go to the VS Code marketplace, like you just search your extensions view in VS Code and say TypeScript native preview, just those words, TypeScript native preview, it'll come up, and it's going to be a faster language service that, if you open up like a kind of big code base, like let's say the VS Code code base or like Sentry or whatever, that would like take 30 to 40 seconds on certain computers before you could like go to definition accurately or like get completions. It's like 4 seconds now, right? and it's snappy and it's responsive. We can talk a little bit about how we made that happen, but I think we're trying to get this stuff in the hands of people now, right? So you can go and get native previews on NPM. We publish all of this stuff nightly, and you can try it out.
Yeah, I love this because my transition to talking about TypeScript 7 was going to be, imagine that TypeScript 7 is out, but you don't even have to imagine it. You can actually use the native preview right now.
Yeah, we have people that talk to us that are at like companies and they've just switched entirely over, and we're like, wow, okay, amazing.
Yeah.
Slack is using it now, like Canva,
Redis, beta
testers. Think of names. Yeah.
Yeah. I think we've had a lot of really amazing collaboration with people at different companies who are understandably upset about their TypeScript compile times and their editor responsiveness and things like that. They're typically working on, I don't know, I've heard the term mega apps, right? Basically like full-scale apps that are fairly large. Think stuff like, you called it out, right? Like Figma, Slack, code bases along those lines, Notion, right? And like they're complex, right? And TypeScript is, it's a fast JavaScript based compiler, but it's not able to go at the speed that this new native code base can go, right? And it's not able to use shared memory parallelism, and it's not able to just get that responsiveness that we really wanted to deliver to people, right? So yeah, like they're using it either on the editor side. I mean, obviously at Microsoft too, we have teams using it internally as well, right? Like
we have teams using it internally.
Yeah, we have the team. We have teams. I'm not going to say which, but we have some teams using it, and they're
up too.
Yeah,
yeah. I mean, there's giant. I mean, like Outlook is a web app now. Like
right, Power BI.
Yeah,
Loop,
like they're all
exactly.
big things, and they got big code bases that take too long to load, and now they don't take too long to load. It's like,
yes,
it's great to get the feedback that's like, wow, it's so fast. Like,
yeah,
great.
The feedback we got was switching to the native preview literally saved our life, which is like, I just imagine it like the old compiler, like holding a knife up to, like.
Yeah, I was like, is that hyperbole or is that literally?
I mean, this is literally, right? So
yeah.
you can't. I'm gonna take them at their word, right? It's a good thing.
The new language server just has so much going for it. That's I could iterate all day, like all the different things that make it so much faster than the old one. I mean, there's obviously just one, the language. Duh.
Yeah.
Like we're getting this from the native code element like faster, but then like. In the language server, when the thing that blocks us most is loading all your files so that we can do anything. And like, this isn't like, there are other languages out there that can do a little better because they don't have global types and weird stuff going on. But like, we got to load all your files to then see like, oh, this random file that was pulled in transitively adds a global, like we got to load everything to load your stuff. But in the new code base, like we can just run all your cores and just load everything up because like, the memory usage isn't going to increase from that because we got a load of the files anyway. So we're just racing to see how fast we can get there. And so if you got your 20 core machine and like you're loading up your code base, we're going to load as many files as we possibly can at any given time as fast as we can.
So like disk IO is now my bottleneck?
Yeah. Yes. Which is its own interesting thing. But because depending on like your OS, like doing it in TypeScript before, we would load one file at a time. So we'd make a synchronous call to give me the file contents, and the next one. And like it can be faster in some OSs to not do that and say like, I would like to load 30 files now, please. And then it sort of runtime will manage that for us and make it look like it's synchronous, but it's actually asynchronous. And like defending, like if you're on Windows or something and Defender exists and it's like scanning things or something goofy, like it does better with that workload. So you find load times can get faster in that way.
Wait, does the Go runtime actually queue up like read requests? And
yeah.
Oh,
so
I didn't know this.
It's hilarious.
Actually.
So it's not. You won't guess the name of the thing. It's called the net polar. Because it's it's one giant stack for all the file descriptors, more or less. I'm glossing over everything, but when you say os.read, it's actually going to defer that to some other API, so you don't even think about it, and then it's Go. So there's no async await. You don't call your functions. You just write straight line code, and then it deals with it for you and preempts you. And so it looks like you're synchronous, but in fact, you're actually doing a giant epoll call to do read 10 files at once or something, which is pretty handy, and you don't even have to think about it.
That's pretty neat. I mean, I guess like for people out there, if you're familiar with like the waterfall issue of rendering and the web, right? Like you're basically saying like, I need to fetch this component. Okay, now I can fetch this data. Now I can render, and that needs to fetch some data, and now that can render, and then you kind of go back and forth over and over again. And now, I mean, it's a little different, right? Like because we can kind of continue a lot of the work, and it's not like a user-facing thing, right? But that's sort of the challenge, and it's so nice that you can just throw Go routines at this stuff and just say, go do that stuff.
That was the early learning too, is that Anders, when he was testing out Going concurrent like a year ago, he did the thing that everyone probably would do if you have experience doing like thread pooling, which is like, I'm going to make a fixed pool of things and send them work and do stuff. And then I'm like, yeah, but have you tried just like making one Go routine per file? And he did that. It was like 30% faster. I'm like, yeah, well, the runtime is really good at managing this. Like if I think about my Go app with an HTTP server, hit it with like 10,000 calls a second, every single one of those requests runs in a Go routine and you move on. Like it's not really a big deal. I mean, in JavaScript, it's you can make 10,000 promises, sure, and they're not going to run at the same time, but like you're allowed to do that. Like it's just there's resources associated with it, so it's fine. But if I'm in C++ or somebody like languages like that, and I'm like, yes, I'd like to make 10,000 threads now. It's called your OS is now crashing because you're not supposed to do that, right? And that's why languages have to make the choice of like, either I'm going to go async await, or I'm going to force the user to write small thread pools themselves, or there are very few languages that do it that go away. I think Ruby might be similar with this sort of thing.
This prompts a question that I had is, obviously you're going to be like tapping into a lot of Go and maybe even hitting some corners in Go that maybe haven't been hit before. Like, is there any like collaboration with the Golang folks?
Yeah.
And like, what kind of cool stuff has come out of that?
Well, immediately, like day one, we published this thing, and then someone in the Go community tries to compile our compiler with the Go compiler. And then they're like, why is this so slow? And they file an issue on the Go tracker to say like, compiling the TypeScript compiler is too slow. And then someone, the PUDs, PJ, who I know, fixed it. And so like one Go 125 contains a compiler fix that like made us 5 times faster to compile. We're back down. We're back up to like, it takes like a minute uncached to build our entire code base. And like, that's pretty large. Like I can build the entire Go tool chain 3 times in about that time, because it does the full bootstrap or whatever else. So it's kind of like we got this big checker, we got the big giant AST. So we're hitting like limitations that I think are a little less tractable, and I've tried to figure them out myself, but not succeeding too heavily. But like that's one element, and then like obviously we're using the Go language server. So now we have multiple. We can't just fix our own bugs anymore. We gotta like, we're dealing with lots of different things at once.
Yeah, I think the funny thing that was happening like prior to the unveiling was everybody we definitely started hearing people complain like, wow, a rebuild is taking over a minute and a half at a time. So we started having to, like Jake basically recommended everybody start using GoTip, like the latest version, because like there were already some fixes. And it's like, oh, okay, cool. So the next version is going to be faster and it's going to be better. And then after our unveiling of the native, the native port, that happened, and it was like, oh gosh, this is so much, right? Because we were doing what we could, right? Like we were breaking the code base into different components, right? That could be compiled more independently, right? But right, it was just nice to see that the Go team was so, like the Go community had pull requests ready and like was willing to actually like push on this stuff. And then the team has also been very friendly and excited to hear about the effort, right? I mean, they're obviously like very proud as well. They've been happy to collaborate. They've been very receptive, right? So I think there's just been good energy there, and they should be proud, right? Like we've been pretty happy with everything.
We ported a language to a language. I feel like that's unprecedented. We're not doing pprof, right? Where we're compiling TypeScript into WASM into a C binary or something crazy. Like we're front end, so like it's a little less silly for us to be like, yeah, we can port in whatever language.
That was on my question sheet actually. Is like for the future, is there like any thoughts about like compiling like a TypeScript subset to WASM?
You know, I mean, this has come up so many times in the last 10 years, right? And there's always like, oh, but you could do this. No, you could do that. I mean, it's always interesting, and it's not like it's not done, right? You know, obviously there's efforts like pprof, there's assembly script, there's also even within Microsoft, I forget the specific name of this. I think it's like STS, it's like static TypeScript, and it's used by the team that works on I think it's make code. So basically it's like compiling TypeScript down to like machine code that runs on small devices so that kids can program these things. And it's hairy, right? Because like, okay, it always all these things come down to like how much JavaScript is JavaScript, right? Which means how much TypeScript is JavaScript, or how much JavaScript is you know, right? Like it all kind of depends on what you're willing to give up, and then how much of that is like actually what you cared about in the first place. And it's okay to say that actually I'm looking for something that looks like TypeScript, feels like TypeScript in these cases, but it is really hard to reorient a team where like most of the value is not in that place. And so, for example, right, like a good example of this is for that STS, like you've got, what, are you going to have a garbage collector? Like, no, it's supposed to run on really small devices. Okay, so it's going to do reference counting. So you can leak through cycles, right? So are you going to now say you need weak pointers or something like that? Okay, this is not in the spirit of TypeScript anymore, maybe, right?
It becomes a different language.
It becomes a very different language. Similarly, like, okay, you have this thing where you have to say that this is either an int or a number, and then in any place where it has to go in between one or the other, you have to like have some sort of notation saying I need an explicit conversion, or like a special operator that implies no, this is really an int here. It can go through that. So you have to go through the exercise of saying what it is that, like, did you know that was an abstraction? Turns out it is. Are you relying on it? Sure, you are. Like, you sure are. Even when we were working on the TypeScript compiler, it's so subtle unless you truly understand the runtime, right? And so then, right, a great example of this is optional properties, right? Optional properties imply that you have two different types at least, right? Because either the property is set and it has a different shape at runtime, or it's not. How do you model that? Do you basically say, like, actually, no, at runtime, we're going to have one object with 300 optional properties in some way, and maybe they're set or something like that. So there's so much subtlety here. And you can tell that I've really thought this. I don't know. Maybe you can't tell. Maybe I sound really dumb right now. Yeah, like, you know, you can imagine, like, in the chat, I'm saying, like, you could do a C-style union or something like that. There are ways of modeling this stuff, and at the same time, gosh, you really do end up having to have a static definition or using a lot of inefficient stuff at runtime, and there's really no zero cost abstraction in JavaScript for the most part, right? You either truly know what the runtime is doing, or you just eat the cost.
That is the sad story. Like, I have an NDC Oslo this last year about optimizing JavaScript performance, and it kind of comes down to, like, you gotta know how the runtime is executing your code in order to make it fast. So like, it's a leaky abstraction. If you're gonna like squeeze every drop of performance out of JavaScript, you have to understand how the underlying abstraction is implemented.
Totally, right. And I mean, some of this we've had people who really dove into, like, what is V8's profiling generating, right? Like, what is it logging? Was it doing here? Some of it is just like, you know, I spent time learning about how, like, language runtimes work. Oh, it turns out that every time you need to do this thing, you have to check if a thing is initialized again. You're doing that 1,000 times in a loop. That's not cheap, right? That's how when we found out, Jake did that whole thing where we converted to the latest version of JavaScript, or like a more recent version of JavaScript. We started compiling from var, declarations to let and const declarations. Those have an impact, right? Because those need to be checked if you actually hit the statement before you try to access them.
Right.
And so one of the things that I was able to kind of like guess at and basically say, well, you know, like, maybe there's a middle way here where we basically say, like, okay, some subset of our state is all going to be var declarations, you know, the closure state basically, and that avoids it. And that's like, you know, that avoids us having to down level a specific set of syntax. but we needed to kind of know that was what was happening at the VM level, and it's unfortunate. I mean, look, we were proud of a lot of the work we did with the JavaScript code base.
Yeah.
But also, we were really hitting diminishing returns on the sorts of optimizations. I mean, the most promising one before the rewrite was something from Tizian, who works over at Bloomberg, where basically he was trying to get a uniform shape for every one of our like tree objects and type objects and symbol objects.
Monomorphic.
So yeah, exactly. Monomorphize, right? So basically the JavaScript runtime, even if we're using more memory to do it, would basically always know exact fixed offsets on how to get like the same 4 properties basically. And that gave us like a combination of like a 12% improvement and like a 25% improvement, like nothing, right? But it's not a two, like truly we were really impressed, but it was very weird for our API was one of the issues, but it's also not a 2x. And it's not a 5x and it's not a 10x, right? For better and worse, I mean, I guess overall better, right? This new port that we have is 10x, right? I mean, it's going to vary, but like we can use all of your cores, and those we're going to get more cores, right? And
I think didn't Anders say in the Octoverse interview, you can't ignore 10x.
You can't. We saw the chat and we're like, oh crap, I guess we're doing this, aren't we?
What was the threshold? If it was like 2x, you'd be like, eh. But 10x was like, okay.
I guess we better look at this.
I think thankfully we never had to grapple with that. That was definitely a conversation that came up a couple of times. Like, would 2x be enough to do this thing? Right? Actually, looking at, I don't want to jinx it, right? Because I do want to say we're surprisingly far on this stuff, right? And you know, I was proud of the team for how they got the native previews out early on, but we're even more stable now, and we're way farther along with features, and so, you know, in the amount of time that we've had, like we've come really far. So I guess in retrospect, like maybe 2x could have been worth it, but I think it was nice that even single threaded, we were seeing already like 3 to 4x in some cases, right? And then once we added like, okay, now actually do all the parsing and do it all in parallel. Okay, it's at least 8x, if not 10. And actually, it was not until we started like doing parallel checking that it was like truly 10x. And that, so I think like that being able to say that number was what was driving us. Like, no, how much farther can you get there? And then it was like, okay, you really can't ignore that. This is just tough. Right?
I mean, we can argue that parsing, binding, emitting, could be any number x, right? Depending on what machine you're running the thing on. But like checking is the real pain.
Performance is a hell of a drug, though. Like, how do you not just keep going? Like, you could be like, oh, there's more gold in these hills. Let's go.
Jake showed me the profiling tools that the Go community used like years ago. So we were even using this on the JavaScript code base. It's called pprof, or like the one that I'm specifically thinking about is called pprof, and it's addictive, right? Like saying, like someone comes to you and says, I've got a big code base, and even if they're not complaining about the speed, you're like, I wonder if it sucks to compile. And so
yeah, I think did you see the inmer perf changes that Mark Erickson? Yeah, when I talked to him at SquirrelConf about this, he was like, oh, yeah, I'm using pprof to find these. I'm like, oh, great. So yeah, use pprof. But
I think we mentioned it on the show. Eric, you've used it, right?
pprof? I haven't.
Yeah. Okay.
But now I'm going to.
Funny because like 5 years ago when I was using it, I was actually working on Python because the Python language server, Pylance, Pyrite, the type checker, and so on are all in JavaScript, which is because it's kind of like inspired by the design of TypeScript, the way that it works, which I don't want to go into too deeply, but I mean, I could. But like the reason I wanted it is because I've written Go for like 10 years now. Like it's probably the language I've written the most code in, which is kind of ironic and convenient now. But like I was really familiar with pprof, and I was like, oh, I just want to know, like, I'm not happy with the tooling that comes in like the Chrome dev tools or something. And I'm like, can I see memory allocations or something? And then it turned out there was a pprof like integration with Node, like a native binding that gets loaded. And so you can see all the places that are being actually doing allocation. And then it was like, you know, people profiling the code. I'm like, oh my God, we're allocating so much memory for these tokens or something for like comment processing inside of the old like Python tool chain. And I like sped up the entire thing by like 30% by just like saying like, no, you don't need to like do all this stuff right now. Wait until later. and like the heap allocation stuff that you're able to pull from this was pretty helpful. And we found, I think I wasn't on TypeScript at the time, but like I think I sent it over, and Andrew Casey had found like a whole bunch of stuff related to this, and there's other stuff that we found. Like I think I like compiling the team's code base I got made it like, I don't know, like 30 or 40% faster by realizing that we needed to reuse printer objects in our old compiler for like printing ASTs, because they have like a lot of TS ignores, but we produce the errors for them anyway, because like that's a post-processing step.
Mm-hmm.
And so we're like, oh yeah. And then I looked at the allocation, I'm like, oh my gosh, we're allocating this many things, but we're single-threaded. Just put it in a global, and then come back and get it the next time around. And I was like, oh, there you go, 30%, great, awesome. Which is very funny. And now, I mean, if you're in Go, it's built into everything, so you just do the same thing. But like, that's where many of the optimizations of the new Go code come from. It's like, just run the profile and then do it. And that's my general thing, is just write the code how you want to write it, and then profile it later, and then figure out what you need to do to change it. Don't try to like game the system by thinking you know better than the thing until you run it. That's a cross-language thing.
Yeah.
Don't over optimize early. That's
the first thing I talk about in my talk. Measure it.
Yep.
I feel so bad that we wanted to start off with like, what's going on with 6.0, and now we're like, let us tell you, like, we want to nerd out about the new code base as soon as possible.
Well, yeah, sorry.
Yeah.
No,
this is great.
I mean, I'm guilty of it.
Reminder,
also.
please try the native previews, language server, please, and tell us what crashes you see. There's fewer.
On this topic, actually, Eric, you wanted to ask about WASM.
Yeah.
So TypeScript 7, right?
Yeah. I know we're not AOTing TypeScript to WASM.
Mm-hmm.
That would be stupendous for me. That's not what we're doing. I'm thinking more about like embedding the compiler into web apps. Like we want to run the compiler in a web app. Traditionally not able to run Go code, kind of WASM jumps out as like the way. And I know there's been a couple hitches here. I'm wondering if there's any like updates about like doing the TypeScript 7 in WASM.
Yeah. So to be clear, the criteria for us like looking at languages was that we needed to have it to be able to target WASM to even consider the thing, because we're like, well, at the very minimum, the playground has to keep working, right? But there's VSCode.dev in browser only experiences and stuff like that, and then obviously people use it, and so like every languages that we were testing were the ones that were like, yeah, we can do WASM with this thing, and so Go does target WASM, and in fact, someone has already made like a TS Go playground. It does not use the language server in the editor, which for like Monaco didn't support LSP until like 3 weeks ago or something, because it was like a VS Code API thing. That's a whole separate story. But like, so the TS Go playground just uses regular TypeScript to serve like the tooltips, as far as I can tell. Maybe I'm wrong, and I've just read their code wrong. I think they're just importing like Monaco version of everything. I mean, our expectation is that our native preview package today has all these targets, but we can have a WASM one just like ES Build does on ES Builds in Go. And then we can still do the thing where we load it up in a web worker, and then we can still do communication with it, or we can do LSP over it for the live playground. And then depending on how our API implementation goes, like the current prototype that Andrew on our team had worked on, there's multiple communication methods. You're allowed to communicate with it either over standard in, standard out, or over an LSP-like protocol. And so like we can just throw the same information in the same pipe for like a playground, but like for WASM users in a browser, like it's probably going to be the case that things are going to be like async, and like, because like you just can't get away with it in the browser to like load WASM on the main thread and hope that it works properly. There's lots of unknowns there, like the Go perf for WASM is not very good because of reasons. Go has preemption, like you got to be able to unwrap it, and then in WASM is wacky, or like there's actually no indirect jumping at all in the thing. And so if you ever want to like go from here to there randomly, you got to return early from everything you're in, go all the way back up to the top, remember in a global variable that you would like to go somewhere else, and then hit a giant switch statement that takes you back there. And then every single time you switch from one Go routine to another, you do it again, and you do it again, and you do it again. And like, even if I say like, oh yeah, please, I'll run my code single threaded, like it's one flag in the Go code to say like, we're never going to use the Go keyword and like make Go routines. It doesn't matter, because the runtime has to make its own stuff through GC, and it has to do like network polling and like stuff like, file polling, right? And so like, it's kind of unavoidable. And I've tried TinyGo, and TinyGo doesn't unfortunately help with that, as far as I can tell. So that's I mean, our plan is like we're supposed to be admitting WASM to these things, and I have high hopes for that. Originally, when we tested the perf, it was like, oh yeah, if you take the parser in Go and you put it into WASM, it's as fast as the code we've written in JavaScript, and it was like, okay. Later on, it got worse because the way that the code works is different between the different phases, and so it's slower. And it'd be nice to fix those, but I think those are like, unfortunately, like not inherent, but like problems in the Go compilation stuff that people have ideas for, but are not exactly high priority for them.
No, sure. I was going to ask, like, is this like a thing that the Golang team is like thinking about, or is this kind of like, on the back burner?
We're not WASM experts, and they're not WASM experts.
Sure.
And like the WASM port for them, I believe, is maintained by external people, and so it's, we try to get what we can get, and I'd like to improve it, but I wish I were an expert. I'm not. I've read every commit that's gone into their compiler for 7 years, but that doesn't make me a WASM expert, so I can't really fix that, right?
Yeah, I think part of it is definitely the case that it is, maybe there's some wins to be had from like the Go compiler side. There's also potentially changes that can happen in WASM itself, right? So there's a lot of, there's certain languages that are very amenable to compiling down to WASM, right? Like if you're in C or C++, like chances are a lot of the patterns that you do can work pretty well. But there's definitely runtimes where, especially if, let's say you say, oh, I have a garbage collected runtime. I want to use WASM GC. Well, the GC that Go uses doesn't necessarily align that well with that sort of thing, right? Or even with a language like C#, like I've spoken to some of the people on that side, right? Like there's still challenges, right? Because you can have pointers back into the middle of like a value in the stack, right? And so those sorts of things, like I'm not obviously, like not obviously. I can't speak 100% to what the end goals are, but I know that these sorts of concerns or feedback, that always gets considered with these sorts of efforts. So hopefully there's some work on the WASM side too, but also like Jake said, like I'm not necessarily an expert at that. Kind of have an idea about runtimes, but we haven't written unfortunately, we have not written a compiler from TypeScript down to WASM, so we don't know.
Mm-hmm. Exactly. Just crack out the WASM text assembly format and just do it by hand. Just write assembly, skill issue.
That was actually one of the April Fool's jokes that we had years ago, was like maybe as a service we can have like compiler as a service, but it's like artisanally compiled TypeScript. So like you send it on the other end, there's just like, I don't know, someone on a typewriter. Like the people who write a poem for you.
Actually, that'd be super funny.
Yeah.
Funny.
And then you just give it like a little error message, and somehow the typewriter has like a way to do like inverted background color, so you have a gutter for your line numbers. I don't know. Really
hilarious.
Getting into this as I say it out loud now.
It's great.
Yeah.
So one thing that I wanted to ask is there anything that you're like really excited about in the future of TS, especially like that is enabled by this TypeScript 7?
Ooh, that's a tough question.
I mean, it's all been perf. I could speculate on features that we could do, but I don't want to overpromise on those.
I'm going to hold you to your word.
Yeah.
Well, now we can write Doom in TypeScript types.
Right.
And, now it'll be like much faster. Like I'm a Prolog programmer, and now I want to use a Prolog-like language, the TypeScript type system, to write my software.
Yeah, so TypeScript targets JavaScript, and though that's like the universal language everywhere nowadays. And so, what better universal interpreter than the TypeScript type system for Yeah, Jake wants to die right now. I mean, obviously, we're really excited because so much of the demand for years has been like, when are we going to get a native TypeScript, right? So people are excited about that. There's definitely some set of features where we've said, well, we could do that, but it would be so expensive to do. I don't know if that is the case anymore. Like there's definitely still stuff that is expensive, but being able to say like, is this ever used in so and so ways might be really fast, because it actually takes much less time to traverse through these nodes. They're typically more compact. They're typically, I mean, we've made it so that every node access for like certain properties is always monomorphic until it it doesn't need to be, or needs to not be rather. So maybe there's some room for different analyses. Maybe, I don't know. I have other ideas, but Jake, go ahead.
I know there's type position features where like it's too slow for us, maybe we can do them in the future.
Yeah, one feature request for me is like, we talked about at the top of the show a little bit, is like TypeDoc has served us super well, but it's we have some limitations using it. So like Dino has been experimenting with this built-in like doc generation. I think that would be really cool in a native way to do doc generation.
Yeah. It's a challenge, right? Because I think I also come from languages where doc generation is built into the tool set in some way. And obviously like Go also has this as well. But we from Microsoft, we've had things like TSDoc as well, right? But it didn't necessarily come from the TypeScript team. It actually came from another team that needed to do doc generation. So, this is one of those things where I won't say, like never say never, right? But also one of the things that we would be probably more interested in is making sure that whatever API we come up with the new port can actually support that sort of thing.
Definitely.
So, it should be really fast to get all the information for a doc generator and make sure that your new doc generation tool is fast and good and like you're happy with it as well. Right? I think it's actually very cool that Dino has that built in too. Will we see the same thing from other runtimes? I actually don't know. Like I could see that more with something like Bun. I don't know if Node would try to adopt that because in a lot of ways, like us, they're also trying to keep a smaller scope of what they're doing. Really do one thing well and kind of shine in that way. I don't know. Does that resonate with you, Jake?
Yeah. I mean, it's always scoping is the problem. We have lots of stuff to do. We've tried to de-scope ourselves a little bit.
Right.
Who knows? I mean, we're basically maintaining 2 compilers right now. So who knows what it'll be like in 6 months or a year.
Yeah, it's funny because the near term priority is so much this new thing and like get it out the door, right? Like we need to really narrow focus and really, make sure that we're not too distracted on things, and it's easy to get distracted on. We want tooling to be good and fast and fun. So we, as you can tell, we can get nerd sniped really easily. Just look at this conversation.
I love it.
Yeah,
I'm super glad that we're getting this. This is so cool. Like the 10x aspects, the future prospects for tool developers also really excites me now that like potentially compiler APIs are just extremely fast. So like the types of tools we can build now, I think are going to be unlocked above and beyond like doc generation. We can do wild stuff potentially that I'm not even thinking about.
Well, I mean, one thing that's come up in the latest Octoverse TypeScript #1 language, and one of those drivers is LLM and AI adoption. So do you guys have thoughts about like what the next version of TypeScript, the native version, will like unlock for AI assisted development?
Yeah, I think, in a lot of ways it's still technically a hypothesis, right? We definitely feel like it's that sort of increased growth in TypeScript is correlated with use of AI tools, but also you're growing, and I think it's part of that is because these things reflect the trends of the what humans are doing too, what people are doing in that ecosystem, right? So TypeScript is the choice of most modern JavaScript projects these days, right? But also it's the tool that you would use. I mean, it gives you guardrails for whatever the language model is doing, right? So it's good to have something that can catch errors earlier, and it's even better that it's much faster, right? Because so like an example of this is things like the coding agent in GitHub, right? If you assign something to Copilot today, it needs to try to get these things done. It has a time limit because it's not trying to like go for 4 hours and eat up all your tokens or whatever, right? So it like the faster TypeScript can come back with these results, you immediately get goodness there, right? So you're able to get to the right result faster, one. But it also means that maybe you have a different editing experience that can also kind of like come back with answers that can augment whatever your AI comes back. Basically giving more context, being able to do certain things. And so, I helped work on a project called TypeChat like a year ago. And the idea there was that, things like types and type checking not only can validate that you have data, but it can also like guide the generation of the right, answer, right? So in a similar way, you can say, well, here's the structure of your code. Here are the types that I expect. This is how this should conform. And so maybe your autocompletion gets better. Maybe your agent is coming back with better answers. And then if it doesn't, we can say, no, you done goofed. Come back with something better.
Try again.
And if you can do that really fast, like
And-
maybe that round trip is fast enough to come back with like the more ideal thing, and you don't feel it.
And then also just like our language server can do 2 things at once, 3 things at once, 4 things at
Right.
once, right?
Yes.
So like before old TS server, like if you sent in a diagnostic request, like, and then you started typing again, like we would cancel everything that was going on because it's like, okay, the user just typed. We gotta like cancel everything we're doing. You have one thread. And now it's like, well, when you type, like it's going to handle diagnostic at the same time as your completion, at the same time as something else that's going on. And so like nothing stopping us from like, well, what other custom requests that can go over the same pipe and like happen at the same time? Can we speculate on changes that could happen in the future and see if they have errors in them? Like there's lots of refinements that are possible. It's like the prospect of us doing this in the old code base was basically like moot, because like the alternative is like spinning up multiple TS servers, whether in the same thread or same process or not. It's like you're still using those resources even though it's like the same stuff the entire time. But now we're all in Mach. So like, well, we could reuse 99% of your project with all the ASTs already parsed, see if one thing is going to be valid or not, provide that feedback over an API, and like you're done, right? And like it's those kind of things were like really
So
unlocking those.
I had a coworker who once said that he described like almost all problems are just a function of how fast you can make something happen, right? And so, when people complain about like one product versus another, a lot of the time is like, oh, it can't do this. Like, oh, it can do that, but it takes more time to do that, right? People don't describe it that way. It's just that like the thing expands either in the time that it takes you to do something or similar. And so I think when people hear a faster compiler, they don't realize what that means for every other part of the experience too.
Yeah,
For sure.
yeah. I think it's going to unlock quite a bit. I mean, we can only speculate, but I could imagine that models themselves, when they spit out code snippets, can actually just check them in line. So, I mean, we might see that start to happen, and then that'll even reduce token usage even further, because then it doesn't have to go back and try to fix itself, and the coding agents are going to get even better. But I think this is a really great place to end on. I mean, my takeaway is that I'm very excited about what's happening with TypeScript, and I hope the listeners are too, because there's so much to be excited about.
Yeah, same. I'm so excited. I'm like champing at the bit. I'm like, I want it now, and I can get it now with the native preview.
Yes.
Yeah, I think
Just go
please
to
do.
Please Code Marketplace, search TypeScript native preview, and please try it.
That's right. Just get started with it today.
We just merged inlay hints last night.
Woo! Sweet. Awesome. Well, thank you so much for joining. I think listeners will get a lot of value out of this, and hope everyone is excited as we are. So go check out the TypeScript native preview in whatever editor you're using, and thank you all for joining us.
Yeah, thank you so much.
Thanks so much for having us, friends. Take care, all.
Woohoo!
6, 7, 8. Just kidding.
Hi, everyone. This is Kamran. I just wanted to thank you for listening to the show, and we hope you enjoyed the episode. If you want to see the show notes, you can check your podcast player or go to typescript.fm, where you'll see a list of all the episodes. If you enjoyed the show, tell your friends, and please rate it on Apple Podcasts or Spotify, because that's how the show grows and gets discovered by more people. If you want to suggest news or a project that should be covered, or just want to say hi, email us at feedback@typescript.fm. If you want to follow us on social, we're both active on Blue Sky. I'm at comronicus.com, and Eric is at ericonerheim.com. You can also follow the show directly at typescript.fm.